Hello again, everybody. Dirk the Engineer here, and I just wanted to give you guys another update on the program. I mentioned last time that I was very close to getting the straight cut, or I think I called it the straight rip at that point, done, and I just wanted to show you that. So I made a few other changes in the program. First, again, we'll just start the program up here. One of the changes I made, I added a written liability waiver statement just in case there's any confusion. Basically, the gist of this is that you guys need to accept that if you're using this program, you're taking responsibility for the actual operation of the machine, which includes, reviewing the G code, knowing what it's going to do, making sure it's not going to break anything, and most importantly, making sure you're not going to hurt yourself in the process. So essentially, the second paragraph here basically says that if you click OK, you're agreeing that you're going to hold me harmless in the event of an accident from any part damage, equipment damage, or any injury, or possibly death that could occur through running the G code on your machine. Okay, I make no guarantees that this is good G code. At this point, I'm just the product of this software is just a text file. Okay, what you do with the text file is completely up to you. So there you have it. So if you click OK, you can get into the program. If you don't, then you can't get into the program. So I went over the jointer and the setup last time. This time the straight cut is ready. So I won't cover the setup or anything like that. So I'll just kind of walk you through the process of setting this up. Here we have what I call an operation origin or part origin. And this is essentially going to be set in reference to the grid that I have developed in most cases, although I left it free that you can define your own. So if you want to make it at the table origin, you can just hit 00 here. Or if you want to set up something in the grid, you can click this button and this dialog comes up and you can say, okay, I can count off from my grid 0, 1, 2, 3, 4, 5 in the X direction and 0, 1, 2, 3, 4 or what have you in the Y direction, and that gives you this grid position. And then you want to say, okay, I'm on the positive side of the pin, so I'll click on positive on the X, and I'm on the positive side of the Y pins, so that essentially means I'm on the positive side of the pin for both X and Y. Now you can do like that, but let's say that you had pins lined up here and pins lined up here. That would mean your part exists in here, and you have to take that into account when you define your cut vectors and stuff like that, because everything in the vector is going to be related to where this point is. So if you want to make a cut down here, it has to be minus Y and minus X, whereas if you define positive positive, that means that, let's say the origin is here, that means your part is laying out in this half. That means you can use your kind of normal way of thinking about things, that X positive is going to go this direction, Y positive is going to go in this direction. Okay, so once you click OK, it's going to automatically write what those values are based on the settings in the grid in the machine. So that makes it a little bit convenient. Now you can just pop pins in the right position in your table, and then reference your part against those pins, and you know exactly where your origin is, so that takes a lot of the setup work away. Makes it pretty easy. That was the whole impetus of doing the big grid on my table, so that I could eventually get to the point where I was doing this kind of stuff. So then the next thing that you want to do is define a cut vector. Okay, so let's just say that we're gonna, that the origin was at maybe right here on our table as we were using our white space as our table definition. Let's say that our origin is here, and I want to lay my part it's a board, let's say, and I want to rip it to a certain width. Okay, so now I'm going to define my cut vector. Okay, so point 1, let's say I wanted to make it 4 inches wide. So I would say I want to start at x equals 0, y equals 4, and let's say that my board dimension, let's say it's 20 inches in the x direction and 4 inches in the y direction. That means that I can go down to 20 and 4. So that's defining a vector starting here and going 20 inches in the horizontal direction and ending here. And that's kind of defining where I want the part to be. Now, the next thing I have to do is decide what side of that vector I want to cut on. And since I'm referencing in the positive direction, I have to put myself as if I'm standing right here and looking at the tip of the vector. So obviously if I want my kerf to be on the left side of that thing, so I'm going to select left side of the vector. You can also select right and on the vector if you want to as well. Okay, now the next thing that you want to decide is whether or not you want climb or conventional cut, and you do that by selecting the whether you want it to cut forward, which is nothing selected, or cut reverse, which you select in this direction. I generally like to do a climb cut, especially with harder woods like maple. It tends not to tear out the wood as much. So that means that I need to run from this direction. Let's see, is that right? Let's see here. No, that means I actually have to do the opposite, because the bit spins clockwise. Okay, is that correct? Yes, the bit spins clockwise. So that means that it's going to be coming around into the work this way. So you want to go from left to right in this case, since you're on the top of the board. If you're on the bottom of the board and making an X direction cut, you want it to go from right to left, which is why in the jointer it always goes in that direction. It's always set up to climb cut, because that's the only real safe way to do jointing in this arrangement. I should mention actually that I tried at one point going in the other direction, and if you have a little bit of a heavy cut, it can actually split the wood out depending on how the grain is running. But if you do a climb cut going this direction or this direction, you'll never have that problem happen. Okay, so now we know that we are climb cutting by going in this direction on the top of the board. You can then work on your material properties. Let's say that we're cutting a standard 1x, which is 0.75 inches thick. We've already said that the material direction or material dimensions are about that. Now, this isn't really so important for this particular module, but what that does is get the gantry out of the way for mine. So let's say that I had a 20-inch long and I wanted my cut to be 4 inches. It's actually going to look at that, and the final position is going to be at the safe Z height, 6 inches past this in the Y direction and 6 inches past this. So it's actually going to end up, way out here, so that it's clear, but it's not going clear up to the edge over here, so you waste a lot of time if you're doing multiple part processing. Okay, it's got the materials set up. Tool diameter, well, again, we'll use the 1/2 inch there with 1 inch cutter length and sticking out from the tool holder by about 1/4 of an inch. So total length is about 1 1/4 inches from the collet. That just helps us get an idea of whether or not we're safe with our Z height and gonna extend. Eventually, I'll end up getting a checks in everything like that, so that it doesn't make sure you're not going out of bounds anywhere. Again, we've seen this before. Safe Z height 3. Over travel in this case is about the same idea, except it travels 1 inch past each end of the vector, and that just gives you some ways to some flexibility in the system. Okay, so z-axis offset, in this case, we're going to reference against the table to make that cut. And so we want to leave that offset at 0 so it doesn't cut into our table at all. It may leave a very thin piece on the bottom, but just a quick wipe with sandpaper takes that right off. All right, I'll talk about this in a minute, but we'll leave that off for right now because we want to make a regular cut pass like we were making before, in which what that means is that we're going to come down a little bit into the material and go across, and then we're going to back up and we're going to come a little bit farther and go across, down, a little bit farther, down, and then we're going to go across again, and then we'll make our final cut depending on how many cut passes we have. So let's say that we want to make about a 1/4 inch bite each time. That means that we should do 3 cut passes. The cut offset, we'll leave this at say 50 thousandths, so 0.05. Okay, and what that, in this case, the cut offset is going to be to the direction that this side indicates. So our vector is going this way, we're going to the left side, so that's up, away from the part. Okay, if I make it minus 0.05, that means that it's actually going to cut too far into the piece, and so we'll end up with a cut that a piece that has 0.395 instead. So I like to leave this at 0.05 so that our final pass is what actually takes it down to the final dimension. Again, cut pass spindle speed and feed rate are fairly obvious, and again, eventually I'll get this feeds and speed calculator hooked up so it'll pull up the executable. I highly recommend that all of you get GWizard. It will really help you set appropriate feeds and speeds, and that really does make a big difference in how long your tooling lasts in the system. So the final passes, I'm going to do, say, 2 final passes at our mark, at the vector, and again, we'll set it at the highest feed and a slower speed. I'm sorry, highest speed and slower feed rate. Okay, and again, you just hit the generate G code. It'll ask you if you want to do the setup G code, which will take you right to the origin. It'll put the bit right in the middle of the origin, and you can say yes to that. And then again, you can do a test or what have you, whatever you want to do, and hit save. And so there we should have our G code in the folder that we specified from before, and voila, there it is. And let's see here, let's look at the setup, straight cut setup. Again, there's where our origin is, and if we look here, so we should see something in the X range that is about 1 inch shorter than this measurement plus the table origin offset. So that's about right. And the Y origin, it should actually be greater than this number, which it is. So, sorry, it should be greater than this number plus this number, so greater than 14, and plus a half of the tool diameter, so 14.25 plus whatever the Y offset is that you've specified in the settings. So that looks right. Again, it'll put it right down on the table if you've zeroed at the table. So if you run this, it will give you a visual reference to make sure that you've specified the origin correctly, so that when you get this all set up, you've got the right pins to reference your part off of. Okay, so then straight cut test. This should produce G code that's very similar to that jointer. We have, how many do we have? We have 3 and then 2. Okay, so it picks it up. It rapids to the start. It goes down to 0.5. Now, why is it going to 0.5? Once again, I found a bug while I'm doing a video, which makes me look awesome, but that's alright. Somehow it's picking this up instead of the safe Z-axis, I think. So I have to check out why that is. Sorry again, guys, but it's good that I'm finding these things as I go through. I haven't actually run... Oh, no, actually, that's right. Because we chose to do cut passes 3, and we're starting with a material thickness of 0.5, so yeah, the first pass should be at 0.5. Okay, so we'll do our feed from... We should be going from right to left, which that is lower than this. Okay, so that's good. So then picks it up and it rapids over back to the starting, goes a little deeper, then feeds again over to the same point, picks up, goes back to the start on a rapid, goes down to the bottom, and then feeds all the way over. Now we've adjusted the feed rate and the speed. Okay, so it's going to pick up and go back to the start and go all the way to the bottom, and now, yes, it's moved in the right direction, so it's moved towards the origin, and so that's feeding all the way over on the feed position, and then it picks up and goes back and sets down and does a drag or a feed again, and then it turns the spindle off, and then it picks up and it moves to the right position. So that should be 6 inches past this number and 6 inches past that number, I think, right? Roughly. No, it should be, yeah, this has part of the offset in it, that's why it's 7 inches past each of them. Okay, so it actually is producing the right G-code. Okay, so now let's look at this horizontal nibble. Okay, basically what this does is allow you to do kind of straight line profiling cuts that have, with bits that have an undercut in it, like a bullnose bit or like a tongue and groove bit. So if you wanted to, instead of advancing vertically and doing your nibble cuts across, if you wanted to advance horizontally, you know, for instance, do a cut this way and then move over some closer to the wood and do a cut this way and then move it even closer and, you know, do that way. That's what this is for. So it allows you to kind of nibble in the horizontal plane rather than in the vertical plane. And it uses the same idea, except that in this case you are going to be nibbling from the nibble offset to the cut offset. Okay, so in the case that we were just set up to do, it's gonna go up to 4.5 and do the first pass, and then kind of come down to, I don't know what, 4, well, let's see, I don't know what, let's do cut passes of 5. Okay, it's going to start at 4.5, then go to 4.4, 4.1, 4.4, 4.3, 4.2, 4.1, and then 4. So it actually will do one more cut pass than what you have specified here, I think. Is that right? I think it would do 4 in this case, yeah. And that would be right. So then again, the final passes don't change. It's just kind of setting that profile and making sure that there was no flex in the system and just smoothing that profile off in case your feed rate was too high or what have you. Okay, so that's the idea. So we can go ahead and generate that code. Let's see, if I do 2, it should actually make 3 passes, and it should be at 1/4. Let's set this to 0 just to make sure that the numbers come out right. And generate G-code. Okay, and let's just do horizontal. Okay, so it should generate that. And let's look at the cut horizontal. Alright, so again, what we want to look at, I think, is the Y. So it's rapiding to that position. It's traveling on the feed. Okay, so now this should be a quarter, and it is, back, and then it's going to rapid to that position, travel, and then this should be a quarter back, which it is, and it's going to rapid and travel, and then you're going to do your feed, and it's going to be at the same Y. So it is indeed working the way that it should. This is kind of a powerful way of doing things, because it allows you to do a lot of things that you would probably have to define multiple tool paths for in any other kind of vector-based software like Aspire or anything like that. So this will allow you to do like half laps and you know, straight profiles, rabbets. You could even feasibly do planing this way, although probably be a little bit slow because you're only planing in one direction, but maybe there's a reason that you'd want to do that at some points too. So so yeah, it basically allows you to set a depth, a Z height, and then nibble horizontally in that direction, and any kind of operation that you want to do is good in that direction. The other thing that's nice about this is that this actually allows you to do mitering. Okay, so let's say that we have a 4-inch wide piece. We've just finished cutting it down, and now we want to put a miter corner on there. So let's set the first 0.00, and then we're going to go 4-4. So we're going to put a 45-degree miter on there. And in this case, we're standing at that origin point, and we're looking out. We want the kerf to be on the left side again. Okay, so that's right. And the climb cut, let's see, it's going to rotate clockwise, so this direction is okay as well. Now we could also define the same cut essentially by doing 4-4-0-0. Now we would want to be on the right side of that cut, and let's see here, we would want to cut in the reverse direction. Okay, so this defines the exact same cut, but just in a different way. And one of the things that I want to add yet, but I just haven't had time, I want to put a button in here that allows you to define these points in a different way. Basically, you pick a starting point, you pick a distance, and a direction, and it will calculate what these points are. So I could, in the same way, I could say like, you know, my starting point is 0, 0. I want to cut in a 45-degree direction, and I want to go 6 inches just to get past the edge of my board or whatever. And that would allow you to pick the right points based on that too. So you could do odd angle cuts if you wanted to in that way. And the other thing is, like, if you could then, after you completed that cut, you could say, okay, I want to go down, let's go down to, you know, let's make a picture frame member that is 10 inches wide at the longest point. So let's go 10, let's 10, 0, and then let's go, so we want to, it's 4 inches wide, so we want to take 4 off. That would be 6 and 4. So that would define the vector to cut along, and then that way you would want to be on the right side of that cut, and you'd want to cut, let's see here, it'd be clockwise, so you'd want to cut in that direction. So that would be the correct way to set that up. And of course, you probably, in those cases, you would want to cut by nibbling vertically down into the piece. And again, you'd probably leave a 0.05 and then let the final passes clean it up so that you get a full depth clean pass. So yeah, it is a pretty powerful way of doing things at this point. It gives you a lot of freedom. And in the same way, I mean, you could install like a tongue and groove kind of slot cutter in there, and you could set your axis halfway up. You know, if you could zero it out right, and then you could do the math and figure out where it needed to be right in the middle. But let's say, you know, 0.375, that's halfway up. Now you're going to be cutting a slot into the material. Actually, let's see here. We would want to probably go from 0 to, let's say, make it a 1/4 inch deep. So we would go 0.2, and then we'll maybe do some final passes at 0.2. That'd be minus 0.25 and minus 0.2. Okay, so that would make a 1/4 inch slot horizontally into the side of the piece, and you could put a spline in there to do a spline miter. So that's kind of the idea of how you'd want to set that up. You guys can play around with it and test it if you want. And yeah, I think the next thing that I'm going to do is slotting. That way I can do dado moves, and I can do internal slots. That will also work for doing mortises if you you know, clamp your pieces in right, and we'll go from there. So hope you enjoyed this, and hope you guys can start using it and giving me some feedback. I really appreciate it. So I'll talk to you soon, and look forward to seeing you soon. Bye now.